Okay. If you are on your computer, if you are on your phone, if you are chatting with people, now would be the time to stop any of those activities. Bless you. Qualitative analysis. We're all about solubility now, so you will be using page 4 of your data booklet a lot, okay? In qualitative analysis, you are going to be given a test tube or a beaker, and it's going to contain a solution that contains some unknown ions. Probably not just plus. And you'll be like, I know my solution contains one or more of those, and I have to figure out which ones. Okay, that's what qualitative analysis is all about. Is X in there? Is Y in there? Is Z in there? Okay, so we're going to consider a beaker. In this particular case, we have it contains either calcium 2+, or lead 2+, or both. How did I get to calcium 2+ from calcium CaNO3 Yes. It dissociated. And what happens with the NO3? It also becomes an ion. What kind of an ion is it going to be? An anion, yes. But more importantly, a spectator ion, yes. Okay, because nitrates are soluble with what? Nitrates are soluble with what? Everything. Why is my pen not working? Oh my God. Okay. So what we're going to do is we're going to use a technique called selective precipitation, which means we select an ion that will precipitate and it won't precipitate the other thing. Okay, so we need to pick something that will precipitate the calcium or the lead, but not both. So I would like you to go to your data booklet and see if you can find something that will precipitate calcium or lead, but not both. Page 4. Oh, look at that. Yes. We have chloride or bromide or iodide. Those will precipitate the lead, but not the calcium. Did everyone follow that? Are the people who are talking right now following that? Chloride, bromide, and iodide will precipitate the lead, but not the calcium. Is there another substance on here which will precipitate one but not the other? Yes? What is it? Sulfide, yes. So you could choose sulfide because it will precipitate, well, we don't see lead, but we know that calcium is soluble. And so lead is not in that list, so lead would be down here. So you can choose any of those ions. Okay, so our options are Cl minus, I minus, Br minus, or S2 minus, and we're just going to pick one. Is it, which one do you want to pick? Cl, excellent. We'll choose Cl. But you could choose anything else. Is it possible to add chloride? What's with this pen? Chloride ions all by themselves. No, all ions come as part of a compound. So you need to pair up your desired ion, in this case the chloride, with a partner that will not take part in a reaction. You want to pair it up with a spectator ion. Yes? So we have a negative ion. Are we going to have to pair it up with a negative ion or a positive ion? Positive ion. Who would you like to pair it with? You can go look on page 4. You could pair it with hydrogen. I'm going to tell you that that's a little problematic, and I'm going to get you to guess why. Why is hydrogen a little problematic? Tell your partner, why is hydrogen a little problematic? It's an acid, yes. And acids will not, like H plus is not necessarily going to sit there like a good little ion and do nothing. Yes? So I want an ion that's going to do absolutely nothing. Do we have any ions that will sit there and do absolutely nothing? Sodium is beautiful. And sodium is my favorite because sodium is really, really common. Could you choose lithium or potassium or rubidium or cesium or francium? Yes. Which ones of those would actually be reasonable choices? Lithium, sodium, potassium, and really the other ones. I mean, you'll see them from time to time just to test the knowledge that all alkali salts are soluble, but you will not choose them for yourself. And quite frankly, sodium is more common than lithium. Lithium is much harder to come by. Okay, potassium is not as hard to come by, but sodium is always your best choice because it's everywhere. Yes? Okay, so what we're going to do is we're going to go back here and we're going to say it can pair with any alkali ion, but you're going to choose Na plus because it is common. Now, NH4 plus is also soluble with everything. Could you tell me why NH4 plus is also not a good choice? And you might want to look on page 5 of your data booklet. It's also an acid. Okay, so we don't want those because they could be reactive with things. So we now have a compound, NaCl. So how much of this compound do we need to add? NaCl. We had to add a lot of it, just tons of it. And in order to say that, we're just going to use the words you add an excess. Yes? Add an excess of NaCl. Add a lot. So if this were an AP exam, they'd probably give you a choice of like a 0.1 molar solution and a 1 molar solution. Which one would you choose? 1 molar. And then you're going to make a statement. You're going to be like, okay, I added some NaCl, right? And in here, maybe I have calcium, and maybe I have lead. And now I add in the Cl minus. What are the possibilities? What two things could happen? Yes. You form a precipitate or you don't form a precipitate. If you form a precipitate, what does that tell you?
There was lead.
There was lead. If there's no precipitate, it tells you there was no lead. It doesn't tell you there's calcium. You have one or the other or both. You have to confirm the calcium. Well, I suppose it could have none. Yeah. Now we want to know, now we know whether or not lead was present. Now let's assume that we got a precipitate. Yes? We're still wondering if calcium is in there. Right? And we've got the precipitate of the PbCl2 precipitate. So our solution is now cloudy. How are we going to tell if calcium is present if we need to precipitate it? Yes? You're going to use a centrifuge to remove all of the precipitate. Yes? Do you remember what a centrifuge is? What does a centrifuge do? Where does the precipitate end up? It ends up at the bottom. And this stuff up here is called the supernatant. But you can just call it the remaining solution. Yes? If you want to call it the supernatant, you can. Now that's lovely. I have centrifuged it. How am I going to separate the supernatant from the precipitate? I'm going to pour it out. That process, anyone know what that process is called? Where you pour the liquid and leave the solid behind? It's called decanting. Okay? Yes. So what happens is, like, if you've got a decanter for wine, it's because if you make wine in like small batches or like just homebrew or whatever, like back in the day, that's how they always made it. They didn't have big fancy filters or anything like that. So the sediment would settle to the bottom. So what you would do is you would decant your wine into a decanter, and it would have like a big wide bottom, so any of that precipitate would then stay there. So decant to separate the remaining liquid, remaining solution from the decant to separate the remaining solution from the precipitate. And decant just means pour off the liquid. And there we go, okay? Your weekend homework is to work on the review. If anyone feels they don't have enough review, I have a second review as well, which you can come to see me about, but I'll have it for you on Monday. There's no precipitation. So what you say is, lead is present. Then you would simply get to see, if no precipitate wanted to go straight to the next step, and we didn't have time to say that.
It smashes things off with no.
If there was.
Can you their hands?
No. Yeah. But it needs to also.
No,
Yes, but you can't carry on through the chloride.
Oh, yes, no. So when you call them to unlike
Let's look. Yeah. So you don't want to use, I want you to take calcium later. So you don't want to use swanton barium. Right? Because those get precipitated calcium later.
Where do we still baby?
It's just easier if you like to complex. Anything you add later. Yeah. It's so basic. My next step. I don't like having to yell to speak to someone half a foot away from me. Oh my God. Thank you. Okay, so let's say you were going to get precipitate with calcium, you could choose hydroxide, then almost everything precipitates with hydroxide. Right? So your only choices are alkali, and we don't want hydrogen, we don't want ammonium. And strontium. Yeah, that takes out the lead, but you still have to excrete calcium.
So what's wrong with them?
If you choose barium, it will also precipitate when you add sulfur. But it will be because your second step is calcium present? Right? So clear solution may or may not contain calcium. What would you like to add to see if calcium is in it? Sulfur. I mean, brilliant, because it would work, but let's use it in I don't know, I feel like it's yes, I do.
Well, it's gonna happen. Like, I don't think I know.
I can't recall this. Okay, hopefully. Well, how can you